So our next task is to use physical laws to remove the number of unknowns, if possible. If we can't, then we're going to use those physical laws to generate a system of equations that we'll then be able to solve. Remember, you want your system to be as small as possible. So, the first task we're going to do is to use these physical laws to remove as many unknowns as we can just by using the equations that we can plug in. So which laws do we have? Well, the first one is Ohm's law. At the moment, we're only dealing with resistive circuits. So really, the physical law that governs them is Ohm's law. From Ohm's law, we get voltage division, or VDiv to make things faster to write. Similarly, we have current division, or CDiv. These two are consequences of Ohm's law. So strictly speaking, we don't need voltage division or current division. We can always just use Ohm's law and get the same answer. However, the benefit of using them is that it makes things a little bit faster. We'll see in the circuit that we do have a voltage divider, but we don't have a current divider. Next is KVL and KCL. I tend to go in this order, from Ohm's law down to KCL. The reason is Ohm's law gives me an equation that I can plug in variables and hopefully just end up getting a number. If I can't do that, I'll progressively go to the more and more complicated ones until suddenly I end up at KCL. Typically, when I use KCL, or even KVL, that's when I'm setting up my system of equations. So let's get started. I'm going to redraw the circuit. Remember that all the resistors are 1 ohm. That's a 10 volt source, and that's a 1 amp source. I can use Ohm's law right now. VR1, so that's R1, is equal to the 1 amp multiplied by the 1 ohm. 1 volt. Now, the question is, can I use Ohm's law anymore in this case? You could argue that I could use Ohm's law here on R5 and R6 because they're in parallel with a voltage source. However, I prefer to jump right into using voltage division because I can recognize that I have a voltage divider. Let's take a look at how I knew that. Remember that a voltage divider looks something like this. I have a voltage source, or it could just be a known voltage, and I have two resistors in series and nothing else. The key is that I have two resistors that are in series, and that series connection is in parallel with a known voltage. So I can use this on R5 and R6, and I can use that to find the voltages, and therefore the currents. Now, ideally, you want to find all voltage dividers in the circuit. In my case, there was only that one. In your case, you might have a more complex circuit where there's multiple different voltage divisions going on. If so, you can use that voltage division principle many, many times. Since we only have it at R6 and R5, we don't need to worry too much about finding others. I can directly write down expressions for VR5 and VR6. Is R5 over R6 plus R5 times my voltage source. Remember, that's 10 volts. All of these are 1 ohm. So this gives me 1 over 2 times 10, which is 5 volts. VR6, similarly, is 1 over 2 times 10, or 5 volts. So I've removed two more unknowns. But is there anything else that we can know? Solving a circuit may require some iteration. In the beginning, I used Ohm's law, but only on R1. I moved on to using a voltage divider on R5 and R6. But now that I know their voltages, I can go back to Ohm's law to find the current. Remember, they're in series as well. Therefore, if I know what IR5 is, I can know what IR6 is. IR5 is going to be equal to the voltage across R5, or 5 volts, divided by R5 itself, 1 ohm. And that gives me 5 amps. Similarly then, IR6 must be 5 amps because they're in series. So I have managed to get rid of 5 variables. I know the voltage across R1, the voltages and the currents across R5 and R6. Like I said, the next step might be to find some current dividers. In this case, I don't have any current dividers, but let's see why. Current dividers are set up as follows. I have 2 resistors and an incoming current, and the 2 resistors are in parallel, and importantly, there are no other paths. Current must go through one of those 2 resistors. I should mention that it is possible to create a current divider with more than 2 resistors in parallel. However, all the resistors must still be in parallel. Now, let's redraw the circuit. And I'm going to focus on these 3 resistors, R2, R3, and R4. We might claim that these 2 are in parallel, and they are. However, remember, there can be no other paths in order for a current divider to work. This path here, the path through R4, is that other path. Therefore, there is no current divider in this circuit. We now have no choice but to make up a system of equations. However, we've gotten rid of so many of our variables that once we start making that system of equations, it'll be as small as possible. The next video will talk all about that.